Okay, 3.1b. So we just talked about how you are charged per unit for water and electricity. This one, we're continuing to talk a little bit more about electricity. And this is, again, it's kind of an interesting lesson, semi-related to budgeting, in that we are talking about how much running certain appliances or things that use electricity will cost you. So you can kind of be aware of that and know what are the big things that are going to cost you a lot of money when you're running them. But the math hopefully isn't too bad, and we have a formula for it. I need to really quick pull it up. We have two formulas we're actually working with in this lesson. I guess three. These two right here at the very top, and then that number of years to pay off new appliance. We're going to be looking at these three formulas. So again, you happen to have your formula sheet with your notes. You'll want to pull that out so we can reference it. So let's look at this first one. It says a certain electric mixer requires 125 watts if you run it for an hour. How much would it cost to run the mixer for a total of 90 minutes at a cost of 10 cents per kilowatt hour? So a couple things here. Whenever you see an appliance or anything, a microwave you see it on, a phone charger, when it says the watts on it, it specifically means it will use that much electricity. It will use that many watts if you run it for an hour. So it does not always say this on those items or in the question. Yeah, if it just said a certain electric mixer requires 125 watts, it is assumed that what that means is if you run it for an hour. So your microwave, might say my microwave is 1200 watts. If you open the door and you see a 1200 W or a 1000 W or a 900 W, that's if you literally ran the microwave for 1 hour. Yeah, and then it would use that much electricity. So it's not as much as you think, but we have to make that assumption. Now, two problems here with figuring out how much we actually used. We're trying to find how much it would cost, but because we ran the mixer for 90 minutes, we're actually going to use more than 125 watts. Because again, it only uses 125 watts if you run it for an hour. And we ran it for 90 minutes. So the first formula you're going to use here is going to be this top one. We need to figure out how much we actually used then. So I'm going to go ahead and copy this over. This is the electricity usage formula. Which is number of kilowatts, we're going to come back to that in just a second, on appliance. So I'm just going to say number of kW, that's kilowatts, times, let's go back here, number of minutes used divided by 60. So that number of minutes used divided by 60, that tells us how many hours divided by 60 tells us how many hours we use it. Because again, you only use 125 watts if you run it for an hour. So if you run it for 30 minutes, well, 30 divided by 60, that's a half, right? It's a half an hour. If you run it for 120 minutes, 120 divided by 60 is 2 hours, and that should make sense. So we're going to plug in here, and we're going to see how much we actually used, because again, we used more than 125 watts. But here's the thing. Notice this says kilowatts, and we are given it in just watts. This is going to happen very often because most electric appliances don't use that much electricity. You are charged per your electric company per kilowatt hour. However, all the little appliances, they don't use that much electricity, so they just say watts. So right at the top here of your formula sheet, you'll want to write this down, but we're going to do this in the next question. We're going to have to convert watts to kilowatts. Yeah. Thankfully, because it is the metric system, all we have to do is move the decimal. If you recall that, from the metric system. All we have to do is move the decimal 3 places to the left to become a kilowatt. So what we're going to do before we can plug in here is take this 0.125 and change it to kilowatts. Now it says move the decimal 3 times the left. Well, I only see 125. Where's the decimal? It's here, right? The decimal is always invisible at the back of a number. I could write this as 125.0, and it's the same thing, right? So here's my decimal. I'm going to go 1, 2, 3. So I'm going to use 0.125 kilowatts instead of 125. Because again, even though on the appliance it says 125 watts, we are charged per kilowatt. So we need to use kilowatts. So there's 0.125. Now we have the number of minutes over 60. We ran it for 90 minutes. Now this is probably not all in one go. I mean, I don't know many things, a mixer that you have to run for 90 minutes. But all we do is plug this in. And this is going to tell us how much we actually use. So take a moment to do that. Okay, so we got, I got 675. Did I do that right? Oops, no, I did not. I did times 90 and then times 60. I was like, that's a lot. 0.125 times 90 divided by 60. There we go. Okay, that makes more sense. Okay, so we use 0.1875. Don't round that off just because it's only 4 numbers. Use it all. Kilowatts. So this is how much was actually used. Again, that makes sense because we ran it for longer than an hour. So it's going to use more than 0.125 kilowatts. Now, what you have to be careful about with these questions, though, is not forgetting what our end goal is. Keep your eyes on the prize. And the prize is, how much would it cost? So this is how much we used. Now we need to find the cost, which is 10 cents per kilowatt. This is actually kilowatt hours. I kind of skim over that. But basically, again, that means you use that much electricity in that amount of time. Yeah. So if it's 10 cents per kilowatt hour and we have this much, what should we do? Multiply. Now, it is right here as well. Cost of electricity is how much you used times the price, but we should know that, guys. So to find the cost, we used this much, 0.1875, and it cost us 10 cents per, so 0.10. This is not going to cost you a lot. You're going to come up with a very small number. So check and see what you get. You got 0.01875. I'm going to write it like that first. This is now money because this 10 cents is money. Now, this means 0.01875. That means this is pennies, right? You ran this appliance for 90 minutes, but it only cost you pennies. That's because it's just a mixer. It doesn't use a lot of electricity. So let's round this off to a set number of pennies. If it's 0.018, what should we round that to? 0.02, we will round it to that. Because again, that's how we see money. So this is what you're going to do for these questions. You're going to find the usage using that formula. Do not forget, we're going to do it on the next question, but as soon as you see the watts, stop yourself, move the decimal, change it to kilowatts. And then once we know how much we actually used, we'll find the cost. Again, depending on the question, your answers might be very small because realistically, guys, even if your parents yell at you for certain things, leaving them plugged in, most small appliances really cost pennies to run. It's the big ticket items like the AC unit, the washer and dryer, the fridge, the TV, yeah, uses a decent amount of electricity. Let's try this again. Oh, whoops, this is a typo. This should say 1. This should say 1. So 1 wireless speaker requires 50 watts, pause. Read again what it says in your formula sheet to do. Change that to a kilowatt. Where's the decimal? Move it 3 times to the left. Okay, so here's the decimal. I need 1, 2, 3 means that I need to add a 0. So this is 0.05 kilowatts. I need to move it 3 times, right? And it's 50, so it goes up. I need to add a 0. Let's keep going. If you run it for an hour, how much would it cost to run 2 speakers for a total of 150 minutes at a cost of 10 cents per kilowatt hour? So once again, we're going to need to use that electricity usage formula here. because we need to know how much we actually used because we ran it for longer than an hour. And not only that, but this is one wireless speaker and we are running two. Very important, guys, to keep an eye out for little things like this. So we can find the usage for one speaker and then multiply it by 2, and that's going to be the usage for 2. So I want you to try it. Once again, the formula is kilowatts times minutes divided by 60. Oh my gosh. Holy crap. Sorry. So I want you to try it. We're using 0.05 kilowatts, not 50. We have the minutes given to us divided by 60. Go ahead and try it. Okay, so our kilowatts is 0.05. Our minutes is 150 divided by 60. Now, I'm going to go ahead and do this right now just so I don't forget, but this is for one speaker and we need 2 speakers. So I'm going to go ahead and multiply this by 2 as well. You can multiply by 2 later in the question. He was trapped in the hole. His toy has a hole in it and it's full of dirt. So I have a pile of dirt in my room right now. So again, I'm going to go ahead and multiply by 2 right now. I could have done it later. You should have gotten 0.75. So careful here, do not put a dollar sign on this. None of this stuff is money. Kilowatts, minutes, that's not money. This is called kilowatt hours now. So this is actually how much electricity we used. Do not forget your final goal, which is to find the cost. So it's 10 cents per. Once again, we've used 0.75. Go ahead and find the cost. Well, 0.75 times 0.10 is what you should have done. This is now going to be money. You should get 0.075. Now again, if you leave it like that, I'll take it. But let's round this off to 2 decimal places. What should this round to? This is 8 cents, 0.08. Again, if you leave your answer like this, I'll take it though. It shouldn't mark it wrong on the test or your homework. So you're going to try this one more time because I want to make sure that you got this. It's 2 steps. Find how much we actually used and then see what the cost is. Go ahead and try it one more time. Okay, let's see. So our usage, oops. Now we have again the kilowatts times minutes over 60. So as I read this, you should have gone blah, 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 blah. Watts. I need to change it to kilowatts immediately. Again, as you're reading, don't wait until the end because you're going to forget. As you're reading, if you see watts, immediately think, I need to change this to kilowatts. So if you didn't do that, your decimal is going to be in the wrong place on your answer. So 20 watts, here's my decimal. I need to go 1, 2, 3. So that means I need to add a 0. 0.02 kilowatts. 0.020, that back 0 doesn't matter. This 0 that I have here does. So that's our KW. Our minutes are 30 divided by 60. So we've got 0.02 times 30 divided by 60. We get 0.01 kilowatt hours. So this is the actual usage. Our cost then is 0.01 times, this case it's 0.05. So we're gonna get a pretty small answer here. Yeah. Okay, so depending on your calculator, guys, I'll make sure this doesn't happen in your homework, but you may have gotten a 5e to the -4th or something like 5, something like that, where you see a -4. It depends on the calculator what answer you get. This means, this is scientific notation. What this means actually is move your decimal to the left 4 places. You guys can recall that. I'll make sure this doesn't happen in your homework, but this is actually 0.0005. So we're gonna leave it like that because this would round to 0. cents. So to run this little appliance for only 30 minutes, it's costing you basically nothing. So again, the point of these questions is for you to be aware that yes, it does cost money to run appliances, but for the little things, it's really not much. It's pennies. The biggest expenses are those huge electricity sucking items, the AC unit or the heater, the washer and dryer, the fridge. Those things can cost you more than $100 a month in electricity. These little appliances are costing you like nothing. So there's one more type of question that we're going to have here, talking about energy savings. So this is becoming a bigger deal, obviously, nowadays, as we worry about conserving resources. There are appliances that run more efficiently, meaning they use less electricity, but run the same way. That's called being efficient. If you can use less resources, but still run the same way, great, you're going to save money. So let's read this question. It says, energy savings often pay for themselves. This means that the savings in energy usage can equal or offset the cost of the item after a certain number of years. So if you're saving money every single year because it's not costing as much to run the item, eventually that investment will have paid off. That's what this is saying, right? If you're saving money every year, eventually it will have been worth it to buy this new item in order to save money in electricity. So it says the Thompson's old water heater cost them $4.55 per year to run. So this is the old heater. This is the cost of electricity. The old heater cost this much to run. Yeah, in electricity. The new one they purchased cost this much when they bought it. This is the new one. Cost this much. However, it's going to save them 31% every year in energy costs. Again, it used to cost them this much per year, but it's going to be 31% cheaper, so that eventually all that money they will have saved will add up to the money they had to spend to buy it in the first place. The question says, in how many years will it pay for itself? So technically, you can figure out how to do this. The formula is not necessarily that complicated, but make a note to yourself. This question does have a formula on the formula sheet. In how many years will it pay for itself? Let's take a look. Hey, number of years to pay off new appliance. We're going to copy this formula over. So let's write that actually. Number of years to pay off appliance. It says cost of the new on top, cost of the new appliance. I'm going to put new app for appliance. And then on the bottom, it's telling us to do something. So don't be confused by this. It says take percentage of old cost to run. So I actually need to do that. Take percentage of old cost. Yeah. So let's go ahead and start plugging this stuff in. On top, I need the cost of the new appliance. What does it tell me is the cost of the new one? Read carefully. $12.40, guys. You got to read carefully. I circled it. New, $12.40. That goes on top. On the bottom, we have to do what it says. Take the percentage of the old cost. So we're going to take 31% of $4.55. You should know how to do that. What should we do to take 31% of $4.55? Well, 31% is a decimal divided by 100. Sorry, it's a percent. We want it as a decimal. 0.31 times, because of means to multiply by 455. And again, the reason why we're using the 455 is because that is the old cost. Old 455. So when you go to Desmos, what I'd recommend you do is hit the fraction button first, or figure out what the bottom is and then divide them. If you try and do this in one long line, it's going to get mixed up here. So I'm going to go ahead and figure out what the bottom is first. You can plug this into Desmos all at once as long as you do it as a big fraction, just like this. the 1240 and then 0.31 times 45. Okay, so I get 141.05 on the bottom. So now I'll go ahead and I'll divide these. So again, what this is here on the bottom, just an FYI, that's how much money you're saving every year, right? It says you're saving 31% of what it used to be. So every year you're saving that money because it doesn't cost as much to run it. It uses less electricity. Okay, so you get 8.79 for this. Now again, guys, be careful. You're not going to get points marked off wrong because obviously, again, in Canvas, you don't put units. However, it might confuse you. Look at what our answer is. Our answer is not money. It says how many years. So that's what it says. After 8.79 years, we'll say it will have paid for itself. Because again, you're saving money every year. So after those 8.79 years, now you have all that money you're saving and it's basically extra, right? All that money you saved basically paid this off. So you're gonna try this one more time and then you're done. The hard part about this question, honestly, is just remembering there's a formula. It doesn't seem like it's a question that does have a formula, but sometimes, again, throughout this class, guys, you'll have formulas like this that aren't super complicated, that have words in them instead of variables, right? So try it one more time here. It's the exact same thing. Just be careful, which is the old and which is the new. Okay, so in how many years will it pay for itself? Once again, guys, there's formula. We have the cost of the new on top, and we need to do the percentage of the old on bottom. So there's a condensed version of that formula. This is the new one. Guys, again, I don't know how to explain to you that you need to read carefully. 23% of the old, because that's the old one, needs to go on bottom. So 0.23 times 370. Of means to multiply. 20 and 3 is a percentage. We should divide with it. Sorry, divide by 100. Okay, I'm going to go ahead and put this on the bottom again as well. This is 85.1. You can plug the whole thing in like I said, but I'm just going to do it like that. Okay, so be careful here. You should have gotten 9.87. Once again, what is this? Actually, this isn't money. This is years. So after basically 10 years, this will have paid for itself. You invested this extra money to actually buy this thing, but eventually it will be worth it because it is costing you less to run. So this lesson, guys, just make sure you're understanding that we're using these formulas in this homework assignment. All of it is these three formulas, and that's it. Let me know if you're confused. Be very careful with those little details, like here, which is the new, which is the old, and here going blah, 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 watts. Change it to kilowatts. Move the decimal 3 times to the left before you keep going. Otherwise, you're going to get frustrated. You're making little mistakes. Let me know if you need any help, though.